So after we've worked all of these generic kind of cases, we get to an application. And like in 8.1, the most important thing to these applications is the actual drawing of the triangle. So here the scenario is about a ski lift. It says to find the length of the span of a proposed ski lift from point P to point Q. A surveyor measures the angle DPQ to be 25 degrees. He then walks off a distance of 1,000 feet to another point we'll call R. At this point, he measures the angle PRQ to be 15 degrees. What's the distance from P to Q? Well, one thing I want to remind you of is that whenever you talk about the name of an angle can be named with 3 letters where the vertex is in the middle, or it could just be named by that letter that's in the middle. So like, for example, here, if we're looking at angle DPQ, then what that means is that if you were to look at a triangle, let's say, this is D, this is P, and this is Q, then this is the angle that they just measured, because that is the letter or the vertex that's in the middle of its name, DPQ. So the one that's in the middle is actually the one that they're measuring, okay? So let's go back to the problem here. Basically, we know that they're supposed to find the length of the span of a proposed ski lift. All right, so we have 2 points, P and Q. Here's P. For example, let's say that here is, let's see if Q could go here. Let's see. Okay. So when he measured this, we have a Q is drawn to P, and I know that because I'm going backwards in its name. Q went to P and P goes to D. So P goes to D. So maybe D is this way. We don't know how far out D is, but it's some distance, okay? I may need to come back and shorten it, I'm not sure. Let's see if it makes sense here. So to find the length of the span of a proposed ski lift from P to Q, a surveyor measures the angle DPQ. DPQ is this angle right here, and they measured it to be 25 degrees. After he measures it to be 25 degrees, he walks off a distance of 1,000 feet to point R. So if he would continue to walk over here, okay, to a point R, now we've got this measurement of 1,000 feet. They then tell us that the angle from PRQ is to be 15 degrees. So let's follow that name. PQR is the name of the angle. So we start at P, we go to R. I wrote this one wrong, sorry about that. PRQ is what it says. So we go from P to R and then back to Q. So the angle that we just measured is this angle right here. And so that is going to be the measure of 15 degrees. The question goes back and says, can you find the distance from P to Q? Well, the distance from P to Q is right here. So that's the distance we need to measure. So like I said back in section 8.1, you lose all idea of what A and B and C are, where they're located and everything, because in this problem here, they used a whole different alphabet even. So what we need to look at is, do we have any pairs of information? What kind of triangle do I actually have information for? Okay. What we see here, if I take all of the extra stuff out. We have, hold on just a second. We have a triangle. One of the angles is 25 degrees. Another of its angles is 15 degrees. And we know the length in between, which is 1,000. This is a S. This is an angle, side, angle. This is an ASA triangle. In this case here, we were not given a pair of information. I have two different angles and the side in between them. My triangle kind of collapsed here, but we do not know the angle across from it here. We can figure it out because if you take the two angles that are given, 15 degrees and 25 degrees, if we were to add the mystery angle in, I'll just call this over here, how about B? So this is side B across from it. So if I take angle B, that should equal to 180 degrees. And so that angle must be 140 degrees. That's that angle. Why do I go and find that angle? I have to have a pair of information. So the easiest thing to do in an ASA triangle is to find the other angle that's missing. Now if we go in there and say, okay, well, it looks like the sine of 140 degrees is compared to 1,000. And that should equal to, so in our triangle, we have this 140 degree angle. We had the side right here of 1,000. I'm looking for this piece right here. He's across from angle R. So angle R was given to us as a 15 degree angle. So this would be the sine of 15. I'm just going to leave that as an X over there for the side between P and Q. Do the arithmetic now. You'll find out that your X is going to equal to 1,000 sine of 15 degrees divided by the sine of 140 degrees. If you'll go to your calculator, 1,000 sine of 15 degrees, and then divide that by the sine of 140 degrees. You'll find that that side is 402.6509. So we'll do 402.65. This was measured off in feet. So the distance between P and Q on this drawing is actually 402.65 feet. And that is our answer to this problem here.